Okay, in lesson 2.2, we had scientific notation with positive powers of 10, and those were very large numbers. So in this lesson 2.3, we're going to have scientific notation again with negative powers of 10. So we're going to have very small numbers. This is on page 45 of your textbook. So the essential question asks, how can you use scientific notation to express very small quantities? And just like we did with the large one, we can find the answer. Write the small quantity as a product of a power greater than or equal to 1 and less than 10 times a power of 10 with a negative exponent. So our problems here will look something like this. 2 5/10 times 10. So far it looks just like the other ones did, just like the large ones did. But this time, you're going to have a negative exponent. And on this negative exponent, it tells you that the number is smaller than 1. This number is smaller than 1. Okay, so we're still on page 45, and they have a problem here they want you to try. It says a typical human hair has a diameter of this small number, small number, meters. Write this number in scientific notation. So in step A, they give you this example that has nothing to do with the problem. They just want you to notice how when you move the decimal point 0 spaces, this is the number. But when you move the decimal point 1 space to the right, the number grows larger. And you move the decimal point 2 spaces to the right, the number is even larger. So what they want you to do here is to notice that as the decimal point moves to the right, it gets larger because these are positive numbers. As the decimal point moves to the left, the number gets smaller because these are negative numbers. So a positive number indicates you have a large number, and a negative exponent indicates you have a small number. So in your book, they do have a block right here and a block right here. And sometimes in this book, whenever I copy it off the computer, they don't have parts of it. So there's actually a block right here in your book, and there's a block right here in your book, and you're supposed to fill those in. So I'm going to fill that in with 3, because I noticed that I moved over 3 spaces, so that would be a 3. In here I also moved 3 spaces, but since I went even smaller, as you move to the left you make the number smaller, I can't use the positive 3. I have to use, oh my goodness, I made that block small, a negative 3. So that's what they wanted you to do in those blocks on your page. Okay, so let's actually tackle the problem that they gave us. I don't know why this block is here on my page. It should actually just be the letter B. Who knows? As I said, when I get this stuff off the computer, it doesn't always match up with what the book is. All right, so they want us to move the decimal point in this number to the right as far many places as necessary to find a number that is greater than or equal to 1 and less than 10. And what number did you find? So I'm going to move this decimal point over 1, 2, 3, 4, 5 spaces. So the number that I found was 2 5/10, because I moved it over between the 2 and the 5. So here I have a number that's less than 10 but 1 or greater. Then it says divide this number by the answer in B. So to me this is the long way. So when you divide them with your handy dandy calculator, you come up with a 0, a decimal point, and then you have 1, 2, 3, 4 zeros and a 1. And then just like you did in your Are You Ready, you want to write this answer as a power of 10. So this comes from the Are You Ready? So that would be 10 to the negative 5th power. So these are the two building blocks that you need to write your answer in scientific notation. Now, to me, I just count over the number of spaces. That's going to be the way I move it as a -5. I went 5 spaces to the right, and I left a 2 and 5/10. These are the only parts that I really need to use. But they make these do longer. I don't know why. So combine your answers. So this is where we combine them. I told you to use the building blocks. So 2 and 5/10, ugly decimal point, times 10 to the -5th. Okay, that's good for that page. Or that part. There's another part. All right, so do some reflection here. Try to figure out what the answers would be, and I'll come right back with them. But at least give it some thought. Don't just wait and copy it down. Think about it and then copy it down. Okay, so reflect. When you move the decimal point, how can you know whether you are increasing or decreasing the number? So moving left is a decrease and moving right is an increase. So really good to have that right in your notes. When you move the decimal point left, it's a decrease. Moving right is an increase. Number 2, explain how the 2 steps of moving the decimal and multiplying by a power of 10 leave the value of the original number unchanged. So when you move the decimal point, one increases and the other decreases the number. So moving the decimal point can increase or decrease the number, and then the power does the opposite. So if moving your decimal point increases it, the power will decrease it. If moving the decimal point decreases it, the power will increase it. That's how it works. So they kind of makes each other balance out. Okay, so writing a number in scientific notation. So we're going to write small quantity in scientific notation. So again, you're going to find that decimal point, but this time you're going to move to the right until you separate out a digit that's 1 or higher, but less than 10. So the zeros aren't counting. So if I move it between the 7 and the 8, that makes this number 1 or higher, but still less than 10. And since I had a very small number to begin with, I'm going to have a negative, and I moved 2 spaces, so that's a -2. So let's try this example 1, which I know it's done, doggone it, which I know it's done in your book, and it's not cooperating with me. There you go. All right, so it's done in your book, but I don't like it, so I'm going to do it myself. So I'm going to write the number down, 0, decimal point. Let's see how many zeros there are. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and then there's a 3. Okay, so locate your decimal point. Well, there it is. And then you're going to move that decimal point over until you have to the left of it a number that's 1 or greater, but less than 10. So I'm moving it over, and if I stop here, I have a 0 to the left. That doesn't help. Keep on going. Still a 0 to the left. Still a 0 to the left, and there it is. I have to go all the way to the end. So how far did I move it? 1, 2, 3, 4, 5, 6, 7, 8. I went 8 spaces. So this is 8 spaces. And when oh my gosh. And when I moved it 8 spaces, I ended up with 3. And yes, I believe that there's a decimal point, but you don't need it. You don't need it there. If you don't have any other digit beyond the 3, you don't need your decimal point. So 3 times 10 to the -8. Now this is negative because I went to the right. This is negative because this number is smaller than 1. I went 8 spaces. That's where the 8 comes in. And I just have the 3. Okay? So I've got another problem on this page. I'm not sure that you noticed it. And this will probably not be very good. It probably won't. Oh, for crying out loud. Okay, now go smaller. Good. Go smaller and get out of my way. Okay, so we have this reflect. So please reflect. Come on back and you'll see my response. Okie dokie. So critical thinking, when you write a number that is less than 1 in scientific notation, how does the power of 10 differ from when you write a number greater than 1 in scientific notation? So the exponent is negative if it's less than 1. The exponent is positive if it's greater than 1. And that's all there is. Again, make sure you have these in your notes. Good things to look back on when you have a test. Okay, this is my favorite part. It's your turn. So pause, give it your best shot. If you make a mistake, then you make a mistake. Whatever. I'm not worried about it. But if you tried, you're always better off for it. So pause here. Okay, so you can see what I have for my solutions. For problem number 4, I have 8 and 29 hundredths times 10 to the negative 5th. So for problem number 8, I took the decimal point and moved it over 1, 2, 3, 4, 5 spaces. I cut the 8 off because that's the only one that I ran into that was 1 or greater, but still less than 10. So I went 5 spaces. That's where the 5 comes from. This was a small number. That's where the negative comes from. And these are my significant digits that are left. Okay, so for number 5, I have 3 and 2 hundredths times 10 to the negative 7. Once again, I took the decimal point and moved it 1, 2, 3, 4, 5, 6, 7. Cut that off at the 3. Notice I always go back past all those zeros. And so when I cut it off at the 3, that left me with 3 and 2 hundredths because I have to keep my significant digits. I went 7 spaces, 7 spaces. This number was smaller than 1, negative, smaller than 1. Okay, and so for the last one, number 6, I went 1, 2, 3, 4, 5, 6 spaces. So that left just a 7 with nothing after it. There's nothing after the 7. Times 10 to the 6th power, 6 spaces. This was smaller than 1, and that makes it negative. Hopefully you were successful. Alrighty, so we're on page 47 here. And here they want you to write a number in standard notation. So they're going to give us a number that's in scientific notation, and they want us to put it back in standard notation, the way we usually see numbers. So this is going to be the number you start with, 2 and 33 hundredths. Now let's look at the clues they gave us. They want us to move by 10, so 1 space at a time, in a negative direction, 6 spaces. They want us to move negative, so they want this number to get smaller. For this number to become smaller, I have to move to the left, 6 spaces. So let's move our decimal point 6 spaces left. 1, 2, 3, 4, 5, 6. So this is where my decimal point's going to be. So I must fill in any empty space with a 0. Whoops. Okay, so my answer is going to be the decimal point, 1, 2, 3, 4, 5 zeros, and the 2, and the 3, and the 3. Now careful here, we never start a number with a decimal point. You've got to put another 0 out in front. But this guy is just taking the place in front of the decimal point because we never start a number with a decimal point. So this would be the number written in standard form, standard notation. All right, so read through these 2, reflect, put on your thinking caps, and then come on back and I will show you the answer. Okay, so for number 7, it says justify reasoning, explain whether 9/10 times 10 to the negative 3rd is written in scientific notation, or is that a 5? I can't see it very well. It's a 5. Okay, it's a 5. Is written in scientific notation. If not, write the number correctly in scientific notation. The answer is no, because the first factor is less than 1. So this is less than 1. This decimal point had to move over one more space, had to move one more time to the right. So moving it one more time to the right would decrease this by 1. So it would turn into -6. So the answer is 9 times 10 to the -6. All right, number 8, which number is larger? 2 times 10 to the -3rd or 3 times 10 to the -2nd? When you're comparing numbers to see who's larger, who's smaller, the first thing you want to look at are the exponents, the littlest number. So -3. -3 ends up here on a number line. -2 ends up here on a number line. The larger numbers are on this side, because think about this goes 1, 2, etc. The larger numbers are over here. These are the smaller numbers. So -2 is larger than -3. That gives you 3 times -2 to be the greater number. So 3 times 10 to the -2nd, because the exponent is greater. Okay, my favorite part, it's your turn. So take your turn. I've had a lot of turns. Take your turn. Then come on back. Alrighty, so for number 9, you can see my answer up top there. And I moved this decimal point 6 spaces to the left. This is negative. I want this to be a small number. If I had gone right, I'd make a large number. So I took that decimal point and I went 1, 2, 3, 4, 5, 6 spaces. I filled all these in with zeros. I have to put a 0 out in front because I can't start a number with a decimal. Keep in mind, this is your scratchy work. That should not be your answer. This should be your answer. I shouldn't see the scratchy work. That's for you, not for me. Okay, so on number 10, I move the decimal point over 1, 2, 3 spaces. I fill the empty spaces in with 0. Put a 0 out in front because I can't start a number with a decimal point. And so this is my scratchy work. Here's the answer. I don't give my scratchy work as answers. And then look at your decimal point for number 11. There it is. They didn't give it to me, but I can find it. I go over 1, 2 spaces. There's where I move my decimal point to. I fill in some zeros. And then I write my answer and I label it with the word meter because we're talking about meters. So a word problem should have a label for your answer. Again, this is scratch work. Your answer doesn't have scratch work. Your answer is your answer, your final answer. Okay, folks, hopefully that was helpful.